Hi, welcome to video 5. In this video, we will learn implementing polymorphism, introduction to contract writing with abstract class, understanding final class and final method, what is static, and understanding with example. And we'll try again understand the need of what is called as polymorphism and slowly get used to what is called as abstraction. The whole idea here is I have something called as figure. That's my first class. Now, obviously, the figure as in will have something in between. Let's not worry about it. So here, I will also have another class, which is called as rectangle. And I have another class out there. Anything you wanted, like circle, trapezium, square, whatever. I'll say circle. So over a course of time, I can have many classes. So I'll have a class which is called as figure. I'll have something called as circle. As of now, just to start with. Now, the whole idea here is I want to define all my generic informations here, and I want all the specific things to go here in here, which is specific. That is what we have discussed it. I hope this is clear. So now let's go ahead and code it to understand. So we can even make a few things which is common for these two people. So I will have area. Now, the whole idea here is the figure has area, rectangle has area, and circle has area. Let me make this way. I will just go ahead and delete this. So, what is the kind of figure? I don't know. Now I have to introduce back what kind of figure is this? Is this rectangle, circle, trapezium, square, anything? So, only when I say this, you try knowing it. So I'm trying to connect all the dots which we had done it in day 4, where you say, I want rate of interest. You will not be able to tell until you say it is current account or savings account. So now, when I say area, the area should be known only for this guy. Okay. So let's get started with this. I will have another package created. I'll call it as day 5. I'll have a package, package com.sdet.day5. That's our newly created package. So I'm gonna have a class here which is called as figure, figure, figure. So I'll have public void area. Now I don't know what is the area of figure, but as of now I'll just put like area of figure is uh, calculating. So something I just because we know that because we have been in discussion, the figure is pretty vague and I cannot understand what is the area of it. So now let me go back, create another class. Here I'll have another class which is called as rectangle. Rectangle. Public void area. Here I will not have a method name called as area. Rather, as of now, I'll say uh, rectangle area. Make sense? Makes sense. I'll say area of rectangle is which is length into breadth. So what I do is quickly I just declare few variables. Private int length, private int breadth. So in order to set the values, I use a constructor. So for constructor, I just go ahead, click on constructor using fields, say OK. So here the values are set. So what is the area of rectangle here? I just put it something like this. Length into breadth. That's perfectly fine. So what happens? When somebody comes, he will give the length into breadth and find the area of it. So now I'll have another class, which is called as circle. Circle. I think I made a mistake. I would have probably put this extends figure because now it's easy for us to read a rectangle is a figure. So in similar fashion, if I just go back to circle and say circle extends figure, so now you can read out something like circle extends figure. So my class is perfectly fine, no problem at all. So now, and very cautiously, have a look at this. If I go ahead and compile it, it still works. So just to prove few points, I'm doing little uh, introduction of client. In order to get this, right click, new, create a class. I will say figure client. So what I do is, I'll have a main, I'll have a main. So I'll have rectangle, r is equal to new rectangle, which is length into circle, circle or c is equal to new circle. So hope this is clear. And rectangle, since it has a parametric constructor, it gives you this. So now I can say r dot uh, area, area, which is rectangle area. And very cautiously try understanding. You also have got something called as area, which is from parent. So now I'll say rectangle. Now when I go ahead and click pay, and of course with the circle you will not have anything. So with the circle, what I can do is, with the circle, what I can do is, I can say system.out.println. Since in circle, have a look at this, you have not put anything as of now. When I say, when I say c dot area, this area is perfectly fine. And we know from our previous definition that child class will inherit everything from the parent if it has a access. Probably if it has put something like private, it would have not been access. Since it is public or protected, it is available here. So if I go back and click on play, oh, area of rectangle is 330, perfectly fine. The area of figure is calculating. Now, since you did not override the method, then the invocation of the parent would happen. But you don't have to define it in the child class. You don't have to define that in the child class. So this is where you have to make sure if you are doing polymorphic behavior, overriding of that method is mandatorily required. So now let's go ahead, try putting this. Now I'll say, hey, if I just keep this output here, if I can keep this output here in Notepad, this is my first output. So first, perfectly fine. Now here we have overridden this method. In fact, we are not invoking it. Now figure is calculating coming from figure class. Now let's go back to circle. In circle, I'll say private int something like radius. So for every circle, if you want to calculate the area of it, I want to have the constructor perfectly fine. And let's say okay. So here I want to make sure there are a few things. So what is that thing? I'll go back to source, generate, or I'm sorry, override or implement methods. This time you can go ahead and type it manually, but I'm just taking a little advantage of Eclipse. So here I want to get the area, which is coming from figure. And obviously, you will have its own story of object class, which you want to take it. But as of now, let's keep it here. So I'll say, okay. So what happened? I'm trying to override the area. If I don't have the implementation of the area in my child class, then the invocation will happen to the super class. That's what it happens. You have to understand this output very clearly. Look at this. The output here, area of figure is coming because here in my class, if there was a reference of this method internally mapped by JVM, so it looked there was something called as area. Since I don't have, my parent is showing area of figure is getting calculated. But this I don't want to happen. Rather, this time, what I want is, I would say, hey, I want area of circle is, it's actually pi r square. I feel pi into r. So in order to do that, so here I'll say pi is basically 3.14 into into radius pi r square. That's perfectly fine. Now let us go back to figure client. So here, this guy is troubling. For a simple reason, he needs a parametric constructor. Let's pass something. So I'll say this is area 6. So I'm just passing some value for the circle just to ensure that we have some output. I click on this. When I click on this, oh, this guy has got this output. Perfectly fine. So this is your second output. Second output. So now what happened? These are all perfectly fine, and you could go ahead, try working with this forever, no problem. But the whole idea here to work in a future time as well is something like this. If I have how many kind of figure we have it? We have like rectangle, we have circle, trapezium, rhombus, cylinder, a car, a human. Everything is a figure for me. So I would consider there are like 5 thousands of figures in the world. For thousands of figures, imagine something like this. If I have some team in the world who's calculating area of a figure who sits in United States, and I have area of a circle, people who are calculating this, who sits in some part in Germany. So now everybody has to put their method names because we may just have to understand the difficulty which we have it. I don't like to have all the implementation methods here. Rather, we want to create an array of it, and this should be kept in a business logic. Now, where do we keep it in a business logic? I again go back, try creating a class which is called as figure business logic. So this is something which I want to create. I don't like to have, I don't like to have these stories here, these stories here. So I want to have all my business logic kept here. So in order to introduce this, I'll have public uh, calculate or show figure. Now, very importantly, so if I want to get the polymorphic behavior of that object, so what I do is I will make sure that I'll pass an object first and foremost, which is figure figure. Here I'll say figure dot area. Now look at this. You don't have to do any typecasting. You don't have to do any make or anything until you as a parent and your child have the same method name. You can directly go ahead and invoke it. Perfectly fine. So if I go back here and here I'll comment off this object, or rather I delete it, Here I'll say okay. Figure business logic FBL is equal to new figure business logic. I'll say R FBL dot R FBL dot show figure, which is R. What is there in R as of now? It is pointing to a rectangle. So here FBL dot show figure, which is C. Let's have a look at the output. What happened here? When I click on it, let's see the third output. Let's see the third output. Now, do you see there is all three different outputs? The first time rectangle was shown, the second time rectangle was shown, but unfortunately this time I could not show rectangle. Of course, I can go ahead and try doing it to make sure that I will have uh, my own method because we can do a little bit of typecast. Here I can do the instance of and do all those things, but let's not get into the pain. But the whole idea here if I wanted the area of rectangle to be calculated, I would have probably got a method which is called as area, then things would have gone very smoothly for me. I'm trying to refer to this story because of one simple thing. I'm sure that a lot of us would have used what is called as Siri or Alexa or Google Assistants and all these things. Now, the whole idea of somebody like Alexa in the world is something like this. Hey, Alexa, play me a song. Hey, Alexa, book a Uber. Hey, Alexa, dim my lights. What you did, you're just giving an instruction to Alexa. Alexa is so intelligent that uh, where it increases the volume or decreases the volume, books a Uber, keeps a reminder, plays a favorite song, blah blah blah, all the things. For all the story to happen, there should be some common method which acts. So the idea here is something like this. Understand this very carefully. There is an app which is called as Uber. Uber in fact, if I'm not wrong, I already have this slide. Maybe we did not open this slide anytime. So let's open this and try understanding. This is something which I wanted to do it little later, but yes, let me quickly get this heads up here. This is on interfaces, but I just want to make few things understand. Yeah, here it is. So let's spend a little time and looking into this. This is pretty interesting and very much needed. So I'll go back full screen. So hope this should be okay. Now, the whole idea here is to set the contracts. The whole idea here is to set the contract. If not, what happens? Tomorrow I have like hundreds of diagrams, hundreds of standards will come. Now the idea is if I have a bulb or if I have a thumb drive, what I can do is I can pretty much use this thumb drive in India or US or Germany or anywhere. It is not because of this thumb drive manufacturer. There are somebody on top of this manufacturer. They decide this. Oh, if you are having a thumb drive and it should be of the same size, that's what you have to do it. Now they are all pretty much to do it with the standard. Now, somebody has to define the standard. In our case, who should define the standard? In our case, people who have to define a standard will sit here. Will sit here. We know that there is somebody called as generic. The generic is somebody who has to define all the standards for me. I hope this is making sense. And rectangle, circle are those people who just have to follow the standard. Now I will say, oh, by the way, rectangle, look at this. Rectangle, look at this. So you are my class. You cannot have the method anything just of your choice. You have to ensure the method name is the same method name which is there in the superclass. So what I do is I'm just manually changing it, which is called as area, which I'm changing it as area. So now let's go back and let's have a look at the client. So client has not done any changes, no wow full job. Have a look at your figure business logic. It keeps invoking area. So now when I click on it, let's have a look at the output, the fourth output. Have a look at this. So here it makes more sensible for us. It makes more sensible for us because we know that we are getting the right answer. In case if there are few more methods and few more objects in the world, something like trapezium, cylinder, or whatever, and if they don't override the method of area, then I will find something called as output of figure is getting calculated. The output of figure is getting calculated here is coming from superclass. Is that okay? This guy is coming from superclass. Only when this will come when you have not overridden the method. That's why it happens for rectangle. That's why it happens here for circle. So here it did it, but not with the area method. Now this is happening because of area method, right? So now this is where all our program will start hitting it. Imagine I have another class. another class somebody has created. Let's assume that somebody from India comes as a developer, and this guy's try creating um, a class which is called as Square. Square. So they have their own implementation. They have not followed any ethics, no rules, nothing. So they what they just do is extends a class which is called as figure for whatever properties, and they do their own story. Public void calculate area. I'm just trying to construct some quick uh, stuff where I have a parameter constructor and calculate area. So what they do is system.out.println area of square is here. It's here. I can just say length to length. So perfectly fine. So figure client. So if I want something called as a square, so for all our understanding, what I do is I'm just gonna go ahead and try deleting these two statements. I want to have something called as figure. Figure figures is equal to new figure of like 4 or 5 elements. Figures. I've just put it in a print form. Figures of 0 is equal to new rectangle. Perfectly fine. This is an array, so I just put it a square bracket. So here, let's go back and keep this couple of times. So figure of 1, 2, 3, 4. Perfectly fine. So here I want one circle. Here I want a square. E 44, whatever, no, whatever. So here I want to use something called as for int I is equal to 0, I less than figure start length I plus plus. That's perfectly fine. So what I do is fbl dot show that figure. What is the figure? Which is figures of I. So what is there in the I? It starts from 0 and it goes up to nth limit. So perfectly fine. But here in your business logic, nowhere circle will be shown. Circle will be shown. Now, if I just go back and try saving this guy, Mr. Semicolon, I'm sorry about it. If I click on this play, okay. So here, just to increase our readability, what I can do is I can give a separator just to increase the readability, no other intentions. Here I go to figure client. Here I click on play. Okay. So this is probably the another line which I see is because we have used printf. We have used printf and slash in. That's anyways fair enough. We got to do little work. So here in circle, we did all these things. Plus we put a slash in. Slash in, it will go to new line. It's a carrier's return, right? So I'll click on play. Perfectly fine. Look at this. This is area of rectangle, circle, rectangle. Area of figure is calculating, but who is calculating now? But unfortunately, the square has got calculate area, he will not be involved. So in order to make that polymorphic behavior to draw an area of the same naming convention, it is mandatory. Somebody has to write a rule which says, boss, if you are inheriting. So what happened here is something. Guys, understand very cautiously. This program still works, though you had method anything of your choice. But the whole idea here, we know that in our diagram, from our diagram, this class, which is called as figure, has an area, but this area is not be able to calculate. Rather, the area of figure is calculated at the child class level. Now I have to make sure there's a little interesting thing which gonna happen here. This area method is something is called as concrete as of now. What is my concrete meaning? Have a look at this. Have a look at this. If you go back to the class which is called as figure here, the method, if it has an implementation within the curly braces, these kind of methods are called as uh, these kind of methods are called as concrete methods. But now I have to ensure that this anybody from this class, anybody as a figure class will extend this class, then they have to mandatorily override this method which is called as area. In order to do this, what I do is I introduce one more concept here which is called as abstraction. Abstraction. So the abstraction goes something like this. The first and foremost rule of abstraction is this method, people coming from C and C++, you can easily map it to pure virtual functions. Pure virtual functions. I'm trying to talk very similar. In C++ or C, I'm sorry, in C++, not in C. In C++, you used to instantiate that method with zero. Here we don't instantiate with zero. Rather, we put this prefix with abstract. Abstract. So now understand this very cautiously. Oh, Naveen, look at this. You took out the implementation. Since you took out the implementation, you have put this as abstract. The reason behind having this as abstract is very straightforward. I try saying this class, which is called as figure, says that, hey, look at this figure. This time, this area is not concrete. That will be abstract. This will be abstract. This meaning, this meaning, anybody as a child, anybody who's a child of me, if he or she comes in the world, then they have to override this method, which is called as area, mandatorily. And this is mandatory. If you don't override, the compiler will give you an error. If I don't override, the compiler will give you error. The same thing applies for anybody in the world who is extending me. So tomorrow, if I have a class which is called as cylinder, now this cylinder will have what method? It has to have area. Obviously, we know that, but this time this area happens to be mandatory. Happens to be mandatory. So I just put few pointers right here. Uh, if you need a method which acts as a contract or contract or the rule, then make that method as abstract. First thing, if the method is abstract in the class, then then the class should also be made abstract. I hope this is clear because you cannot have area, it means you cannot have object creation. Now, just to make sure here, look at this very cautiously, very cautiously. I made this as contract concrete for a minute. For a minute, I gotta come back and do little changes. Have a look at this in the client. I can say something called as figure f is equal to new figure. This is perfectly fine. This is perfectly fine. You see there is no error at all. But my whole question to you is, do you want me to allow the developer to create an object of a figure? In fact, there is no meaning for figure at all here. The figure here is only there as a superclass which should tell some common behavior. But for some reason, this is allowing. If I want to stop this to happen, I'll go back to, I'll keep this as it is. I'll go back to figure. We'll put a semicolon. We'll put abstract. Here I'll put abstract and write one more line. The class should also be made abstract. That's what we have done. If the class is abstract, then creating an object of the class is not allowed directly. So hope this is all making sense. There are all like connectors. You have to cautiously read it. You don't know what is the meaning of it, don't make it concrete. You don't know what is area. If you don't know what is area, then do not do it. A very classy examples. What is rate of interest? I don't know. The rate of interest depends on, are you having a current account? Are you having a savings bank account? Are you having a checking account? What? So what you do is, but in the class which is called as account, you will have the method which is called as rate of interest, which is defined, and you have to make that as abstract so that the child class will take a call. What will be my rate of interest? Right? Hope this is making sense. If you are thinking in terms of loans, in the loan you will have something called as uh, EMI. The EMI is not known for anybody at the loan level. They will be known at the mortgage level or at the car loan, or it is known at whatever level. The superclass will only impose a rule saying that I will have rate of interest, I will have EMI, I will have area, and so on. But they don't put the business logic here. Now, if you look at this, now if you look by some chance, if I just go back to any of the class, let's take somebody like Square. So in Square, what happened? There is a whole error which is started showing it because in my Square, what we did, we have a parameter constructor, we have calculate area. So now calculate area is there. If I just hover it, it is giving an error on the left hand side. If you see, let's hover it and try understanding what this guy is all about to say. I'll just zoom in. I just zoom in. It says that the type square must implement the inherited abstract method called as area. Oh, now there is a rule imposed. It says that, hey, look at this. In your superclass, which is, since you are extending from the superclass called as figure, uh, and there is an abstract method which is called as area, and it is mandated that you have to you have to make this class itself as abstract so that anybody of its child will inherit it little later. But as of now, what I do is I'll ensure that there are some good rules followed. For this, I'll make add unimplemented methods. So when I put add in unimplemented methods, did you see this? The story has come of area. Here we have to be very cautious. We are not writing a program, we are writing good. So here I'll just go back and put this here. And this method is not required at all. The things are pretty clear here, very clear. You are in Germany, you are in India, you are in other country. The whole idea here is to ensure that we follow some common rules. This is how most times our Alexas or anybody out there will work. Now, now, if I just go back to client, I should find another error. I'm sure that we would have expected this. You are not allowed to create a, it says that very clearly. Let me just show you. It gives you an error and it says very clearly, cannot instantiate the type figure. Perfectly fine. So now when you say figure, for some reason, the figure is somebody who is the abstract class. Since it is an abstract class, you are not allowed to keep the constructor of it. So you cannot have constructor at all. So the compiler says, no, you cannot have this now. So I'll just go ahead and delete it. Now I will say this program is a full proofed program. So all your standards are placing. Tomorrow, imagine if you are creating a class. So let me also create another class. So I'm sure that we've created many class just to uh, keep little clear. Okay, in figure, I will have to close this. So I'm just trying to create another class. Let's consider I'll have a class which is called as uh, somebody like cylinder, cylinder. That's another class, which extends figure. So the moment you extend figure, look at this, there's an error. There's an error here. You see there is an error in line number 3. So let me just zoom it. There's an error. So what I got to do is just hover it, add an implemented method. You have no authority to write a method anything of your choice. If you are allowing the developer to write the method of his choice, if this project is an amalgamation of somebody like Citibank or HSBC or Standard Chartered, they have like operations in hundreds of countries. Now, hundreds of methods will come. Maintaining that is practically not possible. So we have to have some kind of way where we go with a rule-based development. What is my rule? All the rules which I want, I can put it pretty much in a class, something like figure. This could be anything. You could take account, you could take vehicle, you could take airline, you can take figures, uh, anything for that matter. Let's consider. I want to draw a figure. Public void draw. Now my question is, you have to tell me now. How can I draw a figure? How can I don't know. If I have to draw a figure, something like a rectangle, I may need a scale. But if I want a circle, I need a compass. If I want something a little weird, something like a car as a figure, I may need a lot of equipment. So now what I do is I will, if I should just put here, I'll just put some system dot out or println. I'll say we are drawing figure. So I put concrete. We have to again understand one important thing in the abstract class, the last statement here, in a abstract class, it is possible to have concrete method or methods, whatever you want, concrete methods, and this can be accessed only through child class or classes, whatever. So look at this. I don't have to make any changes. I don't have to make any changes. So let's make, we are drawing figure with scale and pencil. So that's what I want to put it. Is that fair enough? Now in my business logic, I'll just say figure dot draw. And did you see that anybody in my story, it may be circle, trapezium, cylinder, square, anybody for that matter, they will invariably get this method which is called as uh, draw. So let's go back to the client, play, have a look at this. How do you draw? Draw rectangle, we need scale. To draw rectangle, we need scale. To draw rectangle, we need scale. But now, what happened to my circle? Let's have a look at this. Let's go back to circle class. So I'll go back uh, to circle class. Oh, okay, I'm sorry. This is not scaled image. I'm really sorry. So here, I think in our rectangle, we made a mistake. You remember that we have called this a scaled image to draw it. We need a scale and all. Today, you will need a scale. So tomorrow for circle, somebody will write some other method. Let's not have it. I will just go ahead and delete it. I just delete this method. So what I want to go ahead and try drawing this method. So I'll just comment it out. So here, client, let's play. So we are drawing a figure. 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 Scaling. But which figure I don't know. So what you can do is now I can make sure the figure class this draw instead of drawing with pen and pencil, I just put a semicolon and I call this as abstract. Abstract. Since I've said abstract, all the childrens of this figure will have an error. Everybody will have an error. Have a look at this. I'll go back to rectangle. I'll go back to rectangle. There's an error. You see there is a red color underline. I put add unimplemented method. So what? Put this. There's a method which gonna come here. Here I'll say uh, uh, drawing rectangle with pencil and scale. That's perfectly fine. So for circle again hover it, add unimplemented method. This guy will come drawing circle with pencil and compass. Square again go back, square add unimplemented methods. I will have area, I'm sorry, drawing square with scale, right? So cylinder for this guy, let's hover it. The good thing is that he's giving an error. So because we are forced to follow some rules, uh, drawing cylinder with scale, compass, pencil. Maybe like this is like weird diagram. So now let's go back to the client and click on play. Have a look at this. In the rectangle, you can only draw rectangle. In circle, you are drawing circle. In rectangle, rectangle, square, square, rectangle, rectangle. It is very, very clear in terms of what we are doing because we have imposed a rule on the superclass itself. On the superclass, like figure here, say that, oh boss, this is abstract. This is abstract. You have to follow some rules. You just cannot write. This is not about only writing a program. This is all about making sure that we have a nice architecture of the. It's a contract between uh, people, and most times, who does the job of the figures and all? Somebody like team leaders or architects. They do this job. They set the standard. The developers will eventually fall into this category of setting it. Okay, perfectly fine. So now we have introduced two more words. One is called as static and final. So let's understand this quickly, then come back to interfaces. So here. So what is called as final? If I have a class which is called as figure, and if I don't want the class figure to be inherited by anybody, then you can say this class as final. If you say this class as final, then this cannot be abstract and final. I'm sorry, that was the wrong combination. So here, let me write it. Let me write it. If I have a class, and if that is declared as final, my class, then then this class cannot be inherited. I hope this is making sense. If I say final, that class cannot be inherited. I can have a class which is called as my class. I'll have um, method one. You got to cautiously understand this. Method perfectly fine. Now here I can have your class, which is extending my class. You can go ahead, try overriding it. You can override it perfectly fine. So you will have your own behavior. But if I prefix this with final, this becomes, this line becomes invalid. Okay, that's the second usage of final. The third usage of final is to declare constants in the program. You say int x, but you can also say that here it as final index is equal to 33. So this way you are declaring constant. These are three uses of final where you can have it. There's another guy in our screen. One is final, which we have already known it. So what is this final? If you had, I don't know if you could remember that when we did this Java API for 7 or whatever, 7, 8, anything is fine. So here under docs, uh, we had java.lang, which was one of the package. Okay. So here, java.lang. You remember all the classes which we had? You just try opening any class, something like Boolean. Look at that. They have made that as a final class. Any class you try opening it, they have made sure final class because they don't want any Sun Microsystem did not want their classes to be extended by a developer and give a different meaning. So all these classes they have made final. Trust me, over 70% of the classes in Java's documentation, when you see, they are all final classes. They're all final classes. I just want to have a simplest understanding here of a class which is called as to do some simple mathematics. So I'll say simple math, simple math. So here I have a main method. I have a main method. So since we know that main method is probably there, we've been introducing what is called a static from quite some time, but we did not put more focus on this guy. So let's understand. Also want few more methods. One is called as public void. Uh, okay, public int add int number one int number two. Okay, here I'll say return number one plus great. Public int subtract int number one perfectly fine. Return number one plus number two perfectly fine. So what these guys are doing is they're just doing some addition and subtraction. Likewise, all methods which you want, please go ahead and put it perfectly. Now, I want to invoke this add class. I want to invoke this add or subtract. So what I can do is I can say int result is equal to add of 10 comma 20. Unfortunately, this guy does not work. Unfortunately, this guy does not work because these methods which you have in the word are only called as methods. Now we should also know when does the scope of this methods will come into the picture and how it is accessed. So here, try understanding very cautiously. I would just say there are like a few people out there here. I'll just put add and subtract and the same story. So add and subtract with the same story. Perfectly fine. So you say when you want to load something in the method section, so the methods have to be loaded, right? Which is called a subtract or addition, whatever. These methods will be loaded only when you create an object. That meaning, if you have a class which is called as simple math, here is a class. You have to say simple math sm or any variable is equal to new simple math. When I do this sm, this guy will create the memory in the heap of variables. Very importantly, please understand. Plus, it does not stop here. Plus, it will go to SM class. In this class, it will try finding the methods. It will try finding the methods. In our case, we have a method which is called as add and subtract. So it will put two methods here. One is called as add. One is called as subtract. The method which is coming from is simple math. Simple math. Perfectly fine. These are this is what now as you refer if you have imagine if there is a variable which is called as index just for understanding no if I have index so we remember our previous code which we had this is not called as x this is called as sm dot x they should always be referred in this fashion it should always be referred in this fashion. Make sense? So now, if I want to have something like this method, this method cannot be, this is not a subtraction, this is not an addition. This is actually sm dot subtraction, sm dot addition. Make sense? But I also need a little more place where I don't want to invoke, because if you see this usage of add and subtract, this is more of a utility. And imagine over a course of time, simple math, we have like millions of values which you want to create, millions of values. So now I'll say SM simple math SM1, simple math SM2, simple math SM3, and so on. I have like millions of objects. Now everybody has to be creating an object then access it. Not a good idea. Rather, what we can do is we will not have this methods kept in this memory block. I'll get rid of it. There's another block in our world which is called as a static block. Static block. What is stored in the static block? All those methods which come into the world which are prefixed with static. Once they are prefixed with static, for example, here, I'm just trying to put static here. So when I put static, you don't have to instantiate at all. You don't have to instantiate. The moment you put static, when this class is loaded in JVM, the JVM before loading it, it'll try finding in this class, are there anybody who's got the method signature as static? Oh, are you there static? Just come. What is your name? Add. What is your name? Subtract. Which class you come from? Simple math. Simple. Perfectly fine. Now, this way, you will not have multiple instances of the methods. Rather, it will be only one plus loading happens. Loading happens without creating an object. So let's put it here. So here, this does not. If this has to work, what I have to do is I have to do simple math. Sm is equal to new simple math. Then also system dot out dot println addition is uh, add. I'm sorry. Sm dot add. I'm using an instance. Be cautiously knowing it. So 44. System dot out dot println subtraction is sm dot subtraction 44 33. So now if I just go back and click play, hmm, it works perfectly fine. Good. But the whole idea here, if I want 1 million objects, 1 million times to be added. So I have to create this object. That's not a good deal. So if you are my customer and if you are using this utility, everybody who are creating an object, I don't like it. Rather, I will prefix this guy with static. I'll have static. So here, you don't have to create an object at all. Perfectly fine. Just delete it. You invoke add directly. System.out.println add of 33, 44. It works perfectly fine. No problem at all. You don't have to create an object of it if you have the method prefixed with static. So let me write it. You don't have to create an instance of the class if the method is declared as static, right? And all static methods in the world will be loaded before main method. Great, main method, which is again a static method, right? In addition, in addition, in addition, you can also have static block. This is pretty interesting. Now, static block is something like this. Static block. Now, do remember, static blocks will not be able to invoke and they execute by themselves. right? For example, I'll say, hey, from first starting. Now, what you can write it in this block very cautiously, try remembering DB connections, which connections, which you want to do it only once and before all, or opening the files or something out there, right? And you can also have multiple static blocks. For example, I can have static like this. Hey, I am from second static block, and you can have multiple, and all static blocks will be executed in sequential order of their presence. In addition to all these things, you can also have static variables. Static int x is equal to 33. And statics are also called as class level. Because what happens when you say new, that's at the instance level. If you have a static method, static variables, then the entire class will share that entire class. Since it is static, you're not creating an instance of it. They are referred at the class level, as in here. Look at this. They're referred at the class level. So they're also called as class level variables.
Thank you for watching. See you in the next video.